Hello, and thank you for joining me for another video on software design patterns. So today we are going to be going over the bridge pattern. In my opinion, it is the worst named pattern of them all. The bridge really doesn't have much of anything to do with it. But to be fair, I can't think of a better name myself. So, the bridge pattern is used whenever you want to separate the sort of interface of a class, which is to say, the methods that are available to other classes. Whenever you want to separate that from their implementation. And you might say, well, Kyle, inheritance already does that, but it doesn't do it very well. There are certain situations you can find yourself in where a single inheritance tree does not work correctly. And so we'll go over one of those situations now just to sort of demonstrate it. So let's suppose you are creating a calculator, and we're going to use this diagram here to show this off. Yeah, let's suppose that you're making a calculator, and I like using calculators in examples just because they are very simple to implement and everyone really basically knows what they do. So yeah, let's suppose you're doing that, and then your boss comes to you and says, hey, we like the work you did with the calculator, but we have two new clients, okay? One of them, they don't like our current implementation. It only has, addition and subtraction, and they want something more, more spicy. They want division. And then another client, they want multiplication. And you say, okay, I can just whack those features onto the existing calculator. And he says, wait, don't do that because we have, people using the legacy version. They don't want the extra, they don't want the extra buttons. It could be confusing to them. Plus, the client that's doing division, they don't really want to do multiplication, and it could be confusing if they saw another button on there. Likewise with the client that's doing multiplication. So yeah, what you'd end up having to do is creating two sort of subclasses. One is the calculator with multiplication, one is the calculator with division. Okay, that sort of works. And then let's suppose your boss comes to you again and says, hey, great work with the division multiplication stuff. We have this new client, and they want to see the output as an integer. They don't like all the crazy zeros or all the crazy numbers, after the decimal place. They just don't care. They work with really big numbers. The decimal place doesn't matter to them. And you say, okay, I can just do this. I can add an integer calculator subclass here. And then your boss says, yeah, great work, because they only need to do, this client only needs addition and subtraction. However, you might come to you the next day and say, well, our client that does division and our client that does multiplication, they saw the integer calculator, and they really like that. They want to still use the current float version, but they also want to use the integer version. So can you create versions that'll work for them? Now you're sort of stuck with a problem, because you're going to have to either duplicate the division logic somewhere, or the multiplication and division logic, or you're going to have to duplicate the integer logic. And so I guess ultimately, personally, I would decide to just duplicate the multiplication and division logic, so you'd end up with a class tree like that. It'd be an integer class tree with division, integer calculator with division, and an integer calculator with multiplication. And then your boss comes to you, and he kind of, he knows the pain that he's been putting you through, and he says, look, we have this new client, and they're kind of crazy. They want to do both division and multiplication. And so, of course, you facepalm because you know what's coming next, which is, yeah, they kind of want to do that both without integers and with integers. So you can see here that the class hierarchy has gone crazy and the class names have gone crazy, and so this should be a good indication that something is really, really wrong. So you might say, okay, well, where did inheritance actually start failing? So in this case, it actually started failing right here. Whenever you added a formatting change, which is the integer calculator, with an interface change, which is the division calculator. The problem here is that you're changing two different things with the same inheritance hierarchy. And so this leads to, this kind of proliferation of classes where you have to combine, different changes in crazy ways. And you end up with a lot of duplicated logic because in Java you can't do multiple inheritance as you can in other languages, which is a little bit unfortunate, but it's what we have to live with. So the bridge pattern, which I will show you now, sort of fixes this. Sort of, not entirely, but it's better. So what it does, it'll separate the interface, which you can, again, think of for this example as methods that another class can see from the implementation of something, which in our case with this calculator was sort of the output formatting. So yeah, but what you can see is the arrow with the little funny diamond there. I believe the name of the bridge pattern comes from that arrow there, because if you look at it, it looks kind of like a bridge between the two, between the interface hierarchy and the implementation hierarchy. So yeah, I think that's where the name comes from. I think it's a terrible name, but yeah. We're going to go rename things now to show kind of what we're going to work on. So the interface is going to get renamed to the calculator, and the implementation is going to get renamed to a formatter. So you might have a calculator with division, calculator with multiplication. That's your interface, and your formatter might be your integer formatter, or your percent formatter, or just your simple sort of default formatter. So let's go over to Eclipse. I have some stuff written to show you. So this is our lovely main class, array, that's written. So basically you have our calculator here, and that has an add method. It adds 2 floats, and it returns it as a string. This is just for formatting. Normally you probably wouldn't do this. Again, it's a slightly contrived example just to show, but I think it works. But yeah, basically if you're not familiar with this idiom in Java, all it does is it converts this float to a string. That's all it does. And it just, it's a simple way of doing it. But yeah, we have our calculator here, we have our client. So the client has this useCalculator method, and it's going to use this calculator. And you will see later why I'm passing it in like this. This will show, it'll let you see how you can change sort of the implementation without the client having to worry about it. And so what we're going to do is we're going to, create this variable 5 plus 2, which is going to be the result of 5 plus 2. Then we're going to print it out. Same thing with 5 minus 2. I should actually print that. I copy-pasted the code right before. Hooray me. But yeah. And so let's go back to the diagram really quick so you can see sort of what we need to do. So if we look at the diagram, let me do this version. Yep. So you can see we need to create, if you're not familiar with the little diamond arrow there between calculator and formatter, all that means is that the calculator is going to have an instance of the formatter. So in our case in Eclipse, what we need to do is we need to create a new Java class, and we need to call it formatter. So that's what we're going to do. And that's going to control sort of the output format of the format of the output, I should say. And so that's going to have a public method, and it's going to return a string because it's going to do formatting to a string. And it's just going to be called format, and it's going to accept float because that's what our calculator does. And so all it's going to do now, the default formatter, as it were, is just going to return this, this value that we already have. So what we can do, is we can create an instance of it here, set it to a private field, and call this the formatter. And we can say that's going to be a new, just regular formatter, right? And so to test that this is working, we can do formatter.format, and we can just format value. And so what this should do is this should just return these floats as a string. And so if I run the main class here, what we should see is, we see 7, which is the result of 5 plus 2, and 3, which is the result of 5 minus 2. Okay, that's working. So now what we can do is we can actually, maybe we want to display, instead of 7.0, maybe we want to display this as just 7. So what we can do is we can create a new class. We can call it, integer formatter. And we can say that this is going to extend formatter, right? And so usually in Java, if you type if you type the name of the method in Eclipse, I should say, it will suggest an override for you, which is what we want to do. And so in this case, what we want to do is we want to take the float, and we want to do this. We want to say string value, and then what we're going to do is in the parentheses here, we're going to cast that value. We're going to cast it to an integer. So basically what this will do is this will take the value, which is a float. It will evaluate this cast first. So whenever you cast, in Java, whenever you cast an int to, or float to an int, basically it's a truncation sort of operation. So if I had like 5, if I had 2.5, I would get 2, for instance. And we can show that off later whenever we do the, division and multiplication. So yeah, now that we have that, what we can do is we need to, in the calculator, we actually need to pass in what formatter we're going to use, because right now it's hard-coded to the default formatter. So we need to create a constructor. You can also use a setter or a getter or something, or sorry, a setter it would be. You would say, calculator, and then we're going to have a formatter here, and we're going to call it formatter. And then we just say this dot formatter equals new formatter. All right, and so we will also create a default version of this. Yeah, so this is our default constructor. Basically, if the client calls this, they'll just get a default formatter. If they call this version, they can set it explicitly. Okay, so in our main class, what we can now do is in here, is we can say new integer formatter. And then whenever we run this, or whenever we run this class, what we will get is you'll see the zeros disappear here. So I'm going to remove the terminated and then clear the console, and then we can run this as a Java application. And as you can see, it did not work. The reasoning, of course, is probably because I didn't call it. Is that what it is? Why is that? Ah, that's why. Because what I needed to say was formatter, not new formatter. That's why. That's embarrassing. Okay. Yeah, okay, so now you have 7 and 3. So yeah, don't make that mistake. Always assign your variables to the thing that you actually want to assign them to. Okay, and so what we could also do is we could also have, say, a percentage formatter that, it would multiply something by, say, 100, and we'll look at that in a minute whenever we do the actual interface change. So let me go back to the diagram. So as you can see, we have created the formatter class, we created a new subtype of it called the integer formatter, and we didn't even have to change the calculator itself. So now, what if we wanted to add division or multiplication? So what we need to do from this diagram is we need to create subclasses. So we go back to Eclipse and create a new class. We can say, calculator with division. And then we say extends calculator. And then we add a division. And so we would say public string divide, and then we'll say float A by float B. And so one thing that we need to do is we actually need to go back up to the main calculator. We need to change this to protected, not private. If it is protected, we can't access it, or if it's private, we can't access it, but if it is protected, we can. So now we can say return formatter.format, and we'll call that value. And then the value, we're going to say var value equals A divided by B, or not divided by D, divided by B, okay. So now, what we would probably want to do is we'd want to say, public void use specialized calculator. And so this is going to be the, calculator with division, and we'll just call it, basically we'll use the same code here. Yeah, call it calculator, yes, and then we actually need to put the closing parenthesis there, and rather than doing this, 5, we'll say, 7/2, because that'll give us a nice, uneven number there. Number with decimal places is what I mean to say. So yeah, and we have to actually create a new method for this because the calculator itself doesn't have division, so if we tried to put this in here, it wouldn't work. Yeah, because calculator in this case, the calculator interface doesn't actually have division. But this one does. So if we go over to main here, what we can do is we can create a specialized calculator. We can say var, specialized calculator. That's a new calculator with division. It's not what I meant to do. And we can say specialized calculator. Oh, no, sorry. Can create a new client. It doesn't really matter. And say, use specialized calculator, and then grab specialized calculator here, put it in here. And so now this will use, this calculator will have a default formatter on it. And I'm just gonna comment these out because we don't really need to see them. And we can just terminate, disconnect, and then we can run this, and we should get the result of the division, which is 3.5. Okay. And I believe we can actually put the int formatter in there, and no, we can't. We actually need to create a constructor for that. So we need to say calculator with division, and give this a formatter, and then I believe you just call super with formatter. Okay, now that will compile. Basically what we just said to it is, hey, whenever you do the calculator, whenever you have the constructor of calculator with division, all you need to do is just call the superclass, and if we go into it, it's just this version that we created earlier. So yeah, now what you will see is that the 3.5 will actually become a 3 because it's now using the integer calculator. So one thing we could potentially do is we could create a new formatter, a new percent formatter. Let's call it. And then that would extend formatter. And we start typing format. Okay, and then what we can return is we can say the value times 100, and then what we can do is we can cast that into an integer. I know this is starting to get ridiculous, but yeah. So we can cast that into an integer, and then we can add to the end of it a percent sign. And I believe I did that right. So basically, if we were to say, we go into the client and we say we divide, I don't know, let's say we divide 100 by 2, that'll give us 50%, right? So we'll just call this value so that it's a little bit more accurate. And then we go back into main here, and we say, percentage formatter. And let's see, this should give us 50%. Nope, it doesn't. It gives us 5,000% because I'm doing that math wrong. It would actually need to be something like, say, 1/2. That would give you 50%. Yeah, okay. Basically, we're just mapping, 0.5 as a percentage, so the float, 0.5 as a percentage. Or, that to 50%, yeah. Yeah, as you can see, that gives you a way to vary the interface with the implementation. And so another thing to demonstrate there is that if we create this specialized calculator, we can actually pass that in to our original calculator. However, the results will be kind of interesting. We can probably pass in the integer formatter for that. And we can actually use the specialized calculator here. Oh, if I could ever type correctly. That's because the original calculator can still, or the specialized calculator, the calculator with division can still do things that a normal calculator can do. So if we run this, what you will see is you will see that we still get 7 and 3 because we passed in the integer formatter. If we remove it, we'll get the original 7.0 and 3.0. Or will we? We will not, because we actually need this to have a default constructor as well. Okay, that's fine. So if we run this, again, we get 7.0 and 3.0. Okay, so what exactly did all of that just do? So as you can see, we can add various things to the interface. So we can add a division method to the interface without actually changing the formatting. Normally, if you were using the other system, you would have to go in, you'd have to create a bunch of extra classes. So if we go back to our example, what you find is that we have, 1, 2, 3, 4, 5, 6, 7 classes. Whereas if we go into Eclipse, all we have is 1, 2, 3, 4, 5, and we can actually do a lot more than we could do with the original. Again, if I added the multiplication in here and I added the actual other formatting options that they wanted, we could, we wouldn't have to add that many more classes to get to the same parity. So yeah, that shows you how to vary the interface with the implementation. That shows you a simple version of the bridge pattern. Again, I apologize, the bridge pattern is kind of hard to explain, but it's actually extremely powerful. I've been on projects that used it, people didn't really know the name, but they sort of knew what they were trying to do. And yeah, it can be really, really powerful. It basically lets you, mess with the inheritance hierarchy at runtime, which is extremely powerful. And it can deal with, again, situations that I showed you where inheritance itself isn't a great solution. Because remember, we didn't duplicate any logic, whereas in the example that I showed you, there was tons of duplicated logic, which is really a problem. But anyway, if you've enjoyed this video, please feel free to like, subscribe, and share this video with your friends. If you have any questions or comments, please feel free to leave them in the comments below, and thank you for watching.